The next concept we are going to learn is number and sum of divisor. Suppose we have any natural number. As we know, it can be written in form of product of prime numbers and their powers. So n be a natural number, then n can be expressed as product of power of prime number such as 2, 3, 5, 7, 11 and so on. So n equal to 2 raised to power a, where a is power of 2 or the factors of 2 present in n. 3 raised to power b, similarly 5 raised to power c and so on. Then the number of divisors of n including 1 and itself can be written as a plus 1, b plus 1, c plus 1. Suppose we have 21. Its prime factorization can be written as 3 raised to the power 1 into 7 raised to the power 1, where 3 and 7 are prime numbers and these are its power. So the factors of 21 are 1, 3, 7 and 21. Total 4 factors. By the help of this, how can we find out? It is 3 raised to the power 1. So 1 plus 1 into 7 raised to the power 1. 1 plus 1. That is 2 into 2 is equal to 4. This is how, because see 3 raised to the power 1, it means we have 1 power of 3. So we can select it or not. So we have two options. So 7 raised to the power 1. So we can select 7 or not. So we have two options. So 2 into 2 is equal to 4. Now the sum of divisor. If the number n whose power of prime a, b and c and so on given as, so that can be the power or the sum can be written as, if the a is power of 2, if b is power of 3 and so on, c is power of 5. So the sum can be written as 2 raised to the power 0 plus 2 raised to the power 1 up to 2 raised to the power a into 3 raised to the power 0 plus 3 raised to the power 1 up to 3 raised to the power b. Similarly for 5, 5 raised to the power 0 plus 5 raised to the power 1 up to 5 raised to the power c and so on. So how can we write this? This is an GP. The sum of GP is, what is first term here? 2 raised to the power 0, that is a, and 2 raised to the power a plus 1 number of terms minus 1 upon 2 minus 1, which is this term. And for 3, this is an GP again with common ratio 3. The sum is given as 3 raised to the power b plus 1. There are b plus 1 terms, minus 1 upon 3 minus 1. Similarly for 5. And if you have some power of 7 raised to the power d, we'll write same for d. 7 raised to the power d plus 1 minus 1 upon 7 minus 1 and so on. That will depend upon the number of powers present in prime number. Suppose if this is e, 11 raised to the power e, there will be another term 11 raised to the power e plus 1 minus 1 upon 11 minus 1. Now we have to find the number of even divisor of 10800. The first what we do, we will consider n equal to 10800. Now let us prime factorize it. So 10800 can be written as 108 into 100. And how 100 can be factorized? 2 raised to the power 2, that is 4 into 25, that is 5 square. Now what is 108? It is 12 into 9. So what is 12? 4 into 3, that is 2 square. What is 3? Sorry, 9 is 3 square and we have 1 3 from here. It is 3 square into 2 square into 5 square. in total we'll have 2 raised to the power 4 into 3 cube into 5 square. So 2 raised to the power a, 3 raised to the power b and 5 raised to the power c. So total number of even divisor. We need total number of even divisor. For that, any number can be written in form of even if we have at least one power of 2. So at least means 1 or 2 or 3 or 4. 4 options we have here. So in general we have 4 options from here. What about this? We can take 3 raised to the power 0, 1, 2, 3. So 4 from here also. What about 5 raised to the power 2? We can take 5 raised to the power 0, 5 raised to the power 1 and 5 raised to the power 2. So 3 from here. So in total we'll have 4 into 4 into 3. 60 into 3 is 48. So in total 48 even divisor. We are considering 2 raised to the power 1 because we need at least one power of 2 to make it as even. So option D, 48.